Hello, calculus class. This is Alyssa. She can't stop laughing. She's leaving now.
I'm not leaving.
This is Sabrina, still making a video. Sabrina likes to come in during calculus videos. All right. We just started, so it may be a minute. Okay, today we're going to be talking about, if y'all want to stay here, that's fine, just make sure you, shh. Today we're going to be talking about E. E is a number like pi. We learned that from pre-cal last year. E is a number just like pi. It's an irrational number, meaning it can't be expressed in the form of a fraction. It also goes on forever, right? Good paragraph up here. Good history lesson from where it was discovered. A guy named John Napier, Scotsman, came up with the notion of E and the natural logarithm. This is the value for E. This is how it was found. And it's found by limiting this expression as n gets bigger and bigger, like as it goes to infinity. Now you have properties of E. Remember, E is a number, so all the properties of E apply to the, we call these the exponential laws. You'll remember these from pre-cal. E to the power of E plus C. If you add these two together, then it's E to the C, or E to the X, E to the C. Anything to the power of 0 is 1. If you are dividing E over E, then you can subtract the powers, right? E to the bx is E to the b to the power of x. You multiply those together. And then E to the negative bx is 1 over E to the bx. Those are just your laws of exponents. Nothing has changed since pre-cal on those. And then a couple of good things here. Since the natural log is defined as the inverse function of the exponential function e to the x, or since the natural log is the inverse, then a few things can be said. Your natural log is the inverse of e, so you can think of them as they also undo each other. It's kind of like a reverse operation. So if e to the x is y, and you switch x and y to get the inverse e to the y, which is x. So you switch your x and y. That's written as the ln of x equals y. So you have a couple of things. The natural log of e to the x is just x. So if you have an e to the x and you take the natural log of it, it gets rid of the e, drops the power down. If you have e to the power of a natural log, then these two will cancel each other out. Anytime e and the natural log are together, they're going to end up canceling. Okay, these are all of your logarithm rules, and they still apply to this time. If you'll remember from last year, log cabin, which is log C plus log A plus log B plus log, I don't know why I'm still doing this, I plus log N equals log cabin, log cabin, right? Same rules still apply with natural logs. You can separate them or expand them into log A plus log x, natural log A, natural log x. If you're dividing, you can subtract them. If you have the natural log of A to some power, the power can drop in front of the natural log and be x ln A. This one's a really important one here. Okay, so if you have a natural log, your exponent can drop down to the front and be multiplied. The natural log of 1 is 0. This is an important one right here. The natural log of 1 is 0. I'm going to put a little box around this one. That one's a big one. The natural log of e is 1. It's kind of like the natural log of e here canceling out. The natural log of e is 1. The natural log of 0 does not exist. We'll talk about why here in a second. And then the natural log of 1 over x. If you think about this, this is 1 over x, which is really x to the negative 1. So all we're doing is taking the natural log of x to the negative 1 and dropping this negative down here. So you get negative ln of x. So that's all fine and dandy. But let's actually use the jump. Now back over here there was a question why? Why does the natural log equal 0? Well, if we graph the natural log, why does the natural log of 0 not exist? Well, from the from the graph of these things, first the natural log of 1 was 0, and it goes something like this. It goes here and down the y-axis right here. This is why the natural log of 0 doesn't exist, because it doesn't touch the y-axis. You won't ever have an x equals 0. Kind of like with e, goes right here, and then it's 2.1 blah blah blah, up like this, and then down like this. Right? Oh, and these numbers are in common, 2.1 blah blah blah, 2 point some odd right here. Those numbers are in common. So this is e to the x. This is y equals the natural log of x. And then state their domain and range. So for e to the x, your domain is going to be all real numbers, and your range is going to be from 0, not touching 0, to infinity. And the natural log of x just flips that. Domain and range. Domain is 0 to infinity, and range is all real numbers. So it just kind of flips that. The examples, a couple of examples here. Let me zoom in on these a little bit so we can get a little bit of a closer shot. E to the 2, e to the negative 2. We can join these together as e to the 2 minus 2, which is e to the 0, which is 1. So just a little refresher on laws of exponents. Number 2, e to the 4th over e to the e is e to the 4 minus e. And we actually stop there. We're done with that. Doesn't get any more simple than that, because e is just a number. E to the natural log of 3x. See this e and natural log right here? Those are going to cancel and leave you with 3x. Over here, e to the natural log of 2 is 2. So again, e's and natural logs will cancel out. E to the t ln 2 over 5. Now this is all an exponent. So the first thing I'm going to do is rewrite this here. I've got e to the t over 5 ln of 2, right? And there is a property on the front page that says that if I take this number and it's in front of a log, I can put it up here into this exponent. So I'm going to have like a complex exponent here. It's going to be an exponent within an exponent. That'll be e to the natural log of 2 to the power of t over 5. Remember, this is a property right here of logarithms, that I can take this number in front of the log and make it an exponent of my main number. So e and ln will cancel out and leave you with 2t over 5. E to the ln of x squared is just x squared. Those are easy. Love them. Then we get into solving. The natural log of 1 over x equals 2. The natural log of 1 over x equals 2. Okay, this is going to go back to a principle of just algebra, really. What I'm going to do, I'm going to e both sides. There's really no way to call it anything easier than that. I'm going to take e to the power of 2, bless you, and e to the power, that's going to be in the calculus video tonight, e to the power of 2 and e to the power of ln of 1 over x. So here's what it's going to look like. E to the ln of 1 over x equals e to the power of 2. Now what that's going to do here is simplify to 1 over x is e squared, which means that x, multiply this over here, divide by e squared, that means that x is going to equal 1 over e squared. So it's really not that complicated of a deal. Just e both sides, and that gets rid of your natural log. If you start with an e, then take the natural log of both sides. Natural log of e to the 2x equals the natural log of 9. These guys will cancel. 2x equals the natural log of 9. The thing you have to be careful of here is not getting rid of this one, not getting rid of this natural log. Natural log of 9 over 2. Expanding here, you're multiplying on the inside, so that's going to start off as the natural log of m squared plus the natural log of n cubed. And then you can expand the exponents down. It's going to be 2 ln of m plus 3 ln of n. If you're a little shaky on the log rules, the log laws, you can definitely come to me. We'll get it straightened out. Expand this. This is ln of m over n to the 5 to the 1/2 power. So I can take that as 1/2 times the natural log of n minus the natural log of n to the 5 . And then you can bring those down. It'll be 1/2 natural log of m. Distribute this out. Bring your 5 down here. Oh, can't see it. Bring your 5 down here. Minus 5/2 natural log of n. Alright, number 11 expresses a single log, so we're going to be condensing these here. This will be first the natural log of p plus the natural log of q to the 3rd power. I need to back up a little bit here. So bring your 3 up, and this is the natural log of p q to the 3rd power. Same thing here. This is going to be the natural log of p to the 4th minus the natural log of q squared, which is the natural log of p to the 4th q squared. So just a little reintroducing to e and the natural log. We did talk about it in pre-cal last year. If you had IB, I'm not sure if you talked about it, so just a little introduction here to it. Next time we'll be talking about the derivative of e and the derivative of the natural log. But I just wanted to give you a brief review about what e and the natural log was before we got into derivatives. Peace.